In this problem, we have to find the number of longest increasing subsequences. So a subsequence is a sequence from original list. So let's say we have a list A, B, C, D. We pick some elements, let's say A, C, D. We can pick all of them, we can pick less of these. But the thing is that we have to keep them in the same order as they were in the original list. So A, C, D. It's a subsequence of this list. But if we write A, D, C, then it's not a subsequence because here D comes before C and then in the original list C comes before D. And we are interested in increasing subsequence. So if A is less than C is less than D, we are good to go. This is an increasing subsequence. And there can be multiple subsequences because we can pick and ignore elements. And if a subsequence is increasing, it's increasing subsequence, and we are interested in the longest possible such subsequence which is increasing, and there can be multiple of those. So we have to return exactly that is the count of such increasing subsequences, the longest of those. So let's take an example quickly. So in this case, let's list down some of the subsequences which are increasing, like 1 3. 1 3 is increasing because 1 followed by 3. Similarly, 1 5 is also increasing subsequence, but we can form a bigger subsequence like 1 3 5 7. Its length is 4 and it's increasing. You see, 1 is less than 3 is less than 5 is less than 7. We cannot form a increasing subsequence of length more than 4 in this case, but this is not the only longest increasing subsequence. We can also form 1 3 4 7. It also has a length of 4. So in this case we have two such subsequences of maximum length possible. So we return 2. So how can we solve it? So let's see a point. Let's say we have a list which has an element, just one element, 5. Then it's an increasing subsequence in itself. So every element itself is an increasing subsequence and its length is 1 and its count is 1 because there is just one element. So there will be just one subsequence of length 1. So we will start with that concept. So we have an array of the same length corresponding to each index, and this denotes the length of longest increasing subsequence ending at index I. So we can initialize it with 1 because each element in itself is an increasing subsequence. So it will be 1 or more. So we have initialized with 1. We will gradually improve it when we start solving the problem from left to right. And here we have additional thing to maintain the count. So this will denote how many longest subsequences end at current index. So we can initialize this also to 1. And now we will gradually make progress. So in the beginning, for first element, we cannot improve further. If we consider till this point, from beginning till this point, it will be 1 1. So we start from here, and when we go to any index, we have some values, and let's say we are at some generic index j, and this value is aj if this array is a. So we are here. So we are interested in all elements before it which are smaller than this. Why? Because if some element is larger, we cannot. If some element is larger and we know that there are 5 subsequences ending here with a length of 4, then we cannot increase this length by appending it because this is smaller, so this will violate that. But if some element is smaller, let's say we are here, this element is smaller, this index is I, this value is AI, and AI is less than AJ, and there are, let's say, 3 longest subsequences ending at AI, and the length is 5. This is length of longest subsequence, increasing subsequence, and this is count. This is the case, and we found that AI is smaller than AJ. So we have 3 subsequences of length 5. These numbers are different, and the last one of all of them is AI. and AJ is more than that. So we can append AJ to all of them, and this will still be increasing because AJ is more than this, and we are keeping the order. So now what is the length here? Earlier it was 5, now it's 6. And what is the count? The same as the earlier count. So this concept we will use. So go to any index j, look for all values less before this, and if it's less, then do like this. But not always. Let's say the count for this AJ was 5. So why would we do that? Now the count will be 4. Count will be remain 3. So we will not gain anything. Or if the length is more, we will also not gain anything. So we will update it only when this value is less than AJ, but not always. If AJ is already bigger, there is no point in doing that. So let's see, we come to 3. We see that what is the LIS ending at 1 because 1 is less. So if we append it, we will get 1 plus 1, 2. So we got a better value. So we update it to 2 and count whatever was count here. So it will remain 1. So now it's 2, 1. So we are done till this point. Next we come here at 5. Look for all the values less than this. 1 is less. So we make it 1 plus 1, 1, 5. We appended 5 to it and we got a better solution, 2. Count remains 1 equal to this count. Next we come to 3. We see that its length is 2, the longest subsequence ending at 3, and which was 1, 3. So we can append 5 here and we will get a better solution. So now it becomes 3. We got a subsequence of length 3, 1, 3, 5, and count will still be 1. Next we come to 4. So we are done till this point. So 1 is less, so we can append 4 to it and we will get 1 plus 1, that is 2. Next we come to 3. Here it's 2, so 3 is less than 4, so we can append 4 to it and its count is 1. So it will become 3. Count will remain 1. Next we come to 5. 5 is more, so we are not interested and we are done. So let me rewrite 1, 3, 5, 4, 7, and we have solved till this point. 1, 1, 2, 1, 3, 1, and 3, 1. And this is LIS and this is count. Next we come here at 7. And we see that 1 is less, so we can make 2. Earlier it was 1. 3 is also less, so we can make 3. 5 is also less, so we can make 4. And count will also be 1. Next we come to 4. It's 3. So it's already 4. So we know we can increment the count to 2. So 3 plus 1, 4. So count is now 2. So let's write the code, then it will be more clear. So let's cast the size into n. We will need it a few times. If n is less than equal to 1, if n is 1, it will be 1. If n is 0, it will be 0. So we can simply return whatever is value of n. Then we will keep the LIS and count of same length. Initialize to 1. We can in fact start from 1. because for 0 index we will not make any progress. Whatever is initialized is the correct value. And we will look for all elements before it. I equal to 0, I less than j, plus plus I. And we are interested only in the case when nums I is less than nums j. In the other case, we will not do anything. We will just skip it, move past that element. So nothing here in the else part. And if lis I is more than equal to lisj, even if it's equal, then it will increase by 1. But if lis I is less than lisj, we will not gain anything. If it's more, then it's even better. If it's equal, even then also we will improve it. So it will increase by 1 because nums j will be appended to all of the lis's. So count remains equal to the count of I because we have appended j to all of them. And one more scenario is that lisj is exactly one less than one more than lisi. So in this case here, if you see when we came to 4, so we were at 7, so we had made it 4 after appending to 5. So 5 had a value of 3 and we had made it 4. And when we came to 4, it was 3, which was 1 less than 4. So we know that 4 is less than 7. So we can append 7 to all of those lis's of 4 and we will get a length of 4, which it already was. So if it's since you can see here, the length will always increase by 1. But let's say it's already there. Length of j is already 1 more than this. So length will not increase because we are appending j to the end of ith element. So we will increment the count. So that is the special case. And that is what we did here. It was already 4. So whatever is the count of this, we append to the count, add to the count of this. So it became 2. Now we are done with this loop. Only task remaining to us is that in this simple example, we had just one element ending at that element, the length was 4. But there can be multiple cases. Let's say we have some peak and then some bottom. And let's say ending here also we have a length of 4. So we can form some increasing subsequence of length 4. So this is less than this, and let's say this is less than this also. So we pick this, not this because it decreases, let's say here, and this one. So there can be multiple numbers ending at which we will get the same length. So we will scan this list again from left to right and we keep track of the maximum LIS, longest increasing subsequence, and we see which values match with this. So we add all those counts. So this is one last thing that we need to do. So this max element returns the iterator to that, so we are dereferencing it to get the longest So now we have the length, the longest length, and finally we will return the result. So in our earlier case there was just one element which matched to this, so the count was equal to the count of that, which was 2. In some more generic case there can be multiple such elements. And the solution is accepted. So let's see what is the time complexity here. So we have 2 loops. We are going through each element of this list and then from 0 to that element. So 1 plus 2 plus 3 plus 4 plus 5 till n. So this is n multiplied by n plus 1 by 2. So this is n square of the order of n square plus n divided by 2, and in the end also we do one scan of this array, so you can add plus n to it, but that does not change the order. So time complexity is of the order of n square. Space, we are keeping 2 lists each of length n, so space is O of n, time is O of n square. Now we can write it in Java and Python also. Converting that should not be easy, so you can skip this part. I will just copy and convert it. You can also use fill array. This should remain same. We can run a loop to find the maximum. Or just and the Java solution is also accepted. Finally, we will do it in Python. or we can get the max also. And the Python solution is also accepted.